Okay, so many options, but the question remains where to connect. Supply side or load side is commonly going to be the big consideration here. And sometimes this question is actually quite easy to answer. Is the system too large for a load side interconnection? Okay, we're moving to the supply side. Now, there may be some difficulties associated with that, but if we want to put in this size of a system, we can't do a load side interconnection. So that is a choice that is often made for us early on, or it may be that we look at different options where we've got a larger or a smaller system looking at the supply or the load side accordingly. Always think about the fact that there's multiple possible points for interconnection. We've kind of touched on this, but we've obviously got supply or load side, as we say here, but also different subpanels. We may have in commercial buildings multiple voltages on site where you have a 277 480 service, but then you have 120 208 transformers supplying other loads in the facility. So you always want to think about those different connection points. And as I said before, we always have to analyze everything all the way back, all of the bus bars, all of the feeders and taps that are associated with our interconnection, and make sure that we're not overcurrenting those. So think about the different points where you could possibly interconnect on the system. Hey, what about access? In some cases, it can be very difficult to get at equipment, and just the physical space around existing equipment may favor one over the other if there's not already a reason to do one because of size, for instance. What about the existing equipment making one or the other impractical? It may be that you're like, you know what? I don't not want to mess with that breaker box over there. I also don't want to get in that thing. Let's stay on the supply side of this, right? So those kind of things may drive what you decide to do. Of course, there's going to be costs associated with these, and those are always a concern that we need to think about as well. But these still may be significant enough that they override cost considerations. What about restrictions from the utility or the authority having jurisdiction? They may have specific size limitations or equipment requirements or other restrictions that point you in one direction or the other. So you always want to pay attention to what's going on in your locality because that may drive some of these choices. And of course, as I kind of alluded to already, what's most cost effective? In some cases, the most cost-effective may not be the practical or even feasible option, but all things else being equal, hey, let's do it the least expensive way. Not the cheapest, the least expensive way we can to do it safe and code compliantly. Here's a good example of, hey, lots of places to interconnect. This gear is all on one building. Right, so lots of different possible points of interconnection. We've got our main service equipment down here inside the building. We've got a rooftop mounted switch along with a panel that's being supplied up there. We've got distribution panels throughout the building, some at different voltages. You just really got to take a good look and see what's there. Of course, it's going to be more complicated on larger buildings, with more equipment and locations being served. But even in residential applications, it's common to have service panels that have feeders running to outbuildings or to second residences or detached garages that have subpanels in them. Always want to consider those options because looking at all of them and analyzing them will allow you to determine which ones are feasible and then which ones will be the most cost effective. Okay, supply-side connections can present some difficulties. They're not always just like the be-all and end-all to putting a larger system in. So we want to think about some options when we determine that the supply side may not be feasible because of some of the difficulties we encounter. The fact of the matter is, on a lot of residential equipment, you just can't do it. A center-fed panel, a lot of those you cannot tap into the insulated bus bar that's between the meter and the main disconnect. The main breaker. There's just no way to do it. You'll violate the listing and maybe create a dangerous situation. Often on commercial equipment, this can be much easier. There's ways to cut in and get in between those two pieces of equipment, but that's not always the case. And sometimes, maybe the supply side looking like not a feasible option. As I said before, anytime you are making that supply side connection and you want to modify that equipment to happen into bus bars, whatever it may be, you always want to consult the manufacturer. Do not want to violate the listing of it. So what are some options that we could do in lieu of a supply side connection? Some ways to, the most I can do on the load side is too small. The supply side is looking really tough. What else could I possibly do? Now, all these are going to require some coordination with the utility. First off is, hey, replace that existing main breaker with a smaller one. A smaller one, right? So an example would be 200 amp main, 200 amp bus bar. Let's replace that main breaker with a new 150 amp main breaker. Now I've got 50 amps of headroom already built in between the main and the bus bar size. And I actually can apply the 120% rule to these values. And now I can get a much bigger system in there than I otherwise would have been able to. Much bigger. So that's definitely an option. Now, we want to make sure that putting this new breaker in is not going to create a problem. And that means making sure that we are not going to have nuisance tripping because the load is too big. Fact of the matter is, for a lot of residential applications, the house never pulls anywhere near what the main breaker size is. Nowhere near it. Now, you may be able to get this information from your utility to peak demand. You could perhaps perform load calculations to determine what that is. That's beyond the scope of this course, but that can certainly be done. And you may just find that, the load isn't anywhere near 200 amps. It's like 108 amps is the most we've ever seen in the last 10 years. Okay, great. Let's go with the 150 here, or whatever the sizes are, whatever it works out to. That is great. But we also want to make sure that we can physically do it. It's not possible with all equipment. Some panels, you just can't replace that main breaker. It's not feasible. So got to verify that that is in fact possible. But this is a way to be able to get a larger system in while still meeting the load side connection requirements. We still have to follow those rules. But because we gave ourselves some headroom, we've increased the possible size of a system on the load side. We can increase the size of the existing service equipment. Hey, that's certainly an option. 200 amp service, upgrade it to a 400. Yeah, easy. Well, it's not super easy, and it's certainly not super inexpensive, and you definitely have to coordinate with the utility there. But if I do that, or maybe I put in a 400 amp panel with a 200 amp main breaker, now I got a lot of headroom. Right? That's kind of like a combination of these two options, smaller main breaker, but also an upgrade. So there's, these are definitely things that you can do, but there is a cost associated with them. And, they're not necessarily within the scope of every PV installer either. This may take coordination with not only the utility and the building owner, but also with an outside electrician potentially. And again, we got to think about the cost there because upgrading that service could be quite an undertaking. Okay, we'll finish up our point of interconnection lesson with, yes, that's right, part 11, a quick look at power control systems, home stretch. See you there.